test my values or the staff size against their values. Yeah, I'll probably look at
There's been a lot happening in the Discord of people like solving their off by one errors by like finding a hidden double. So okay, ladies and gentlemen, let's get to it. Welcome to yet another Game Engine Architecture lecture. Thank you for coming. It's good to see you. How is Homework 8 coming? Because you're all on Homework 8 now, right? Oh, yeah, of course. Right, okay. You don't have to panic too much if you're on Homework 7. I don't think you need to panic too much. If you're on Homework 6, you're in trouble, okay? You are in trouble. Because when we look at our schedule here, we've got about a week and a half. That's it. A week and a half until those autograders turn off. And by turn off, I mean they'll still be on. They'll just start doling out zeros, okay? Thank you for a good semester. They'll thank you for a good semester, and then they'll give you a big zero, okay, for all submissions after that point. The reason we do that is because we do need you to move on at that point. We have to have you move on to your custom feature, which you'll have 2 weeks to work on at the very end of the semester. You can think of that custom feature as your final exam in a way, and we want to make sure you've moved on to it completely, even if you didn't get everything finished. I will tell you, with the time available, I do think it makes sense that pretty much everyone putting in good time should be able to complete Homework 7 or complete a lot of it. So please do what it takes to get to the end of Homework 7, around there, and we'll call it a semester. You'll have a good, high-quality engine you can use for other stuff, and we can move on successfully. If you're not going to make it, that's something you should talk to me about, okay? And we'll have to figure out why. All right, so today we got about 5 days left in Homework 8. Hopefully, those off by 1 pixel errors aren't getting you too bad. I've seen people are generally able to get past them. And the way that they tend to be getting past them is by finding kind of hidden doubles, raw doubles in their source code. I think this morning we had someone fix a bunch of their issues by replacing a 1 with a 1F. And I can't remember who that was. It's kind of shocking that can make a big difference. But go looking for that stuff, okay? Hopefully you won't lose too much time to it. All right. Maybe next semester we'll have a better thought for how we can deal with this. Okay. All right, so you got 5 days left for Homework 5. I have a game engine for you. This is one that may be near and dear to your hearts. This is Blender. Well, you think to yourself, wait a second, I thought Blender was a 3D modeling program. Who uses Blender? Did you know that until their big UI revamp, their Blender 2.8 revamp, Blender had a built-in physics engine. You could script it with Python. It had physics. You could add interactivity and controls to your characters. You could move them around. I remember doing that in high school. In fact, it was a terrible, terrible game. But in high school, I managed to get it running, and it was kind of cool. It is nice because Blender is a big animation and 3D modeling package. And so, within the same program, kind of Adobe Flash style, you could model your characters, animate your characters, and then actually add interactivity to your characters, all without leaving the program. Well, I got bad news for you. It got stripped out in 2019. They got rid of it. No one was using it. Okay? The contributors decided that Unreal and Unity and Godot had passed them by, and it wasn't worth keeping this crusty engine in here anymore. Sometimes that's just what you got to do. You want to focus on what people really care about with your software, get rid of the stuff that's kind of holding you back, and that allows you to move faster on what people really care about. Well, apparently people did care about it, because at least some people went and they kept it going. And now it is known as the UPBGE. What a name, okay? It stands for the Uchronia Project Blender Game Engine. I'm not sure what Uchronia is. Maybe that's a person, a contributor, or a group keeping this thing alive. But they're doing it, okay? They're going for it. As you can see from some of these screenshots, some of these GIFs, the results are pretty impressive. I think you can get a feel for how nice it is to have your animation package mixed with your game engine just by looking at some of these beautiful animations. It uses a drag and drop kind of code and logic editor. It's called code bricks or logic bricks here, as opposed to the blueprint system that Unreal Engine gives you. This engine is literally like just when you download it, you're downloading Blender. It gets distributed as a modified version of Blender that just has the game engine kind of bolted back onto it. And it's a little bit strange, but it does work. It uses the open source kind of Bullet 3D physics library, and it uses the GPL license, which creeps me out quite a bit. It is really nice if you are willing to contribute your changes back to the community, but like, I'm not sure what the implications are. If you make a game in this Blender game engine and then you ship it, well, wait a second, are you violating GPL if you don't like publish your source code? It feels like the answer is probably yes. Which is to say, why would any serious developer ever use this? I don't know. And certainly if you go onto YouTube, you'll find very few tutorials for this because almost no one uses it. I'm not sure what their thoughts were using the GPL license, other than because they are making this engine as kind of an add-on to Blender, they don't really have much of a choice. If they're going to redistribute Blender, they're going to get the Blender license, and it is what it is, I guess. It does make me a bit sad, though. Blender, almost no one cares about Blender using the GPL. Why? Because no one ships Blender in the final product. They use Blender as a tool to create the models, the OBJs, the FBXs, that then get put into a game engine that isn't GPL. Okay? But if this engine itself is GPL'd, I'm not even sure how you use that as a business. Anyway, if you don't want to use coding blocks, you can use Python. I want to show you a little bit of this. I know basically none of this, other than the fact that this is technically Blender. The UI looks a little bit different. I think there's some custom stuff here going on. But all of the UI is available to you. So if you do want to animate, you can go and find those menus. We've got this toolbox of objects that exist for us here. We can bring them in. We can rotate them the way that you would expect in Blender. If you're not used to using Blender, this UI is going to really freak you out. Blender is an acquired taste. Has anyone used Blender? Seriously? It is a very acquired taste. It takes some time to get used to all the hotkeys. If you don't know the hotkeys, you're in big trouble. Okay? And this is after they made all their improvements in the 2.8 update. Before that, it was truly difficult to use. Anyway, we can grab our stuff here, can kind of bring it out. That ladder's looking kind of funky. I'm going to come over here so I can get a nice angle on it. G for grab to bring it up. And there you go. I got a nice little ladder. All right, I want to add some interactivity here because currently this just looks like a typical Blender scene. So we're 3D modeling a little house, I guess. Well, I'm going to go down here and click on this button, and I think we're going to see that there's a new little menu here called Logic Bricks Editor. When I bring this up, right? We've got our dresser object highlighted. I think it's possible for me to create a sensor. A sensor is kind of like an event, okay? And we might say, you know what? I want to respond to a keyboard sensor, a keyboard event. I'm going to click keyboard, and then I'm going to click, well, what key? Well, how about the space bar? Okay, I press the space bar, so now we're going to do something in response to the space bar. I need to add a controller. This controller basically controls, it's kind of a filter. It decides whether or not to actually go through with whatever we're going to do. What should we do? Well, one of the most kind of simple things we can do is just turn the dresser off, make it go away, okay? We could go to visibility here, but we could do other stuff. We could do some motion. We could move the camera. We can do some sound effects. I'm going to go to visibility, and I'm going to turn the dresser off. Now that I've got these 3 blocks right here, I need to link them up Unreal Engine style so that one heads into the other, And now I'm going to press the P button to play. Now I think it's playing, and I'm going to press spacebar, and my dresser's gone. Okay? Now, none of this is very impressive, and this is all I'm going to show you. You know why? Because I barely know anything about this engine. But it's an example of adding some interactivity without any coding to your Blender scene. Okay? So if you really want to, you can go for it, and you can make a GPL'd game. And I look forward to reading all of your source code. And who knows, maybe someone could find your source code and steal it all because the GPL forced you to make it public. What a mess. Anyway, Richard Stallman's going to show up and fight me, I think. Okay, so that is the Blender game engine. The main takeaway here is that someone bolted a game engine onto Blender, and having all of that in one package is a pretty luxurious thing. It's also probably useless, and no one will take it seriously until they get this licensing thing figured out, which they probably never will, because they would have to abandon Blender to do so. So yeah, that's how it goes, I suppose. Anyway, very cool stuff. I'm glad it exists at any rate. It is interesting at the least, okay? Today is kind of an interesting day. We don't have a ton to talk about, and I'll be completely honest, the lecture material, I've kind of run out, okay? You do not have to worry too much about data-oriented design. It will show up in a very abridged version, in a very high-level form on the quiz on Monday, and it will show up on your exam in a small way. Nothing too crazy, okay? And you already pretty much know what you need, but today what I want to do is I want to take you through what it kind of looks like to use an ECS, okay? What does it look like to program logic in more of a data-oriented fashion? Ravi, with his data-oriented Rav engine, is going to actually walk us through a bit of that engine, show us how to use it, and how to write some gameplay code in it. And I hope you'll compare it in your mind to the way that we built our Lua components when we did that kind of game dev day and made a game together a couple weeks ago, all right? And hopefully you'll get a feel for how data-oriented programming changes the way that you think about logic and how you organize it, okay? So we'll do that in a bit. I've got a few announcements. Quiz 5, your final quiz, is on Monday. If you've got a bunch of really good scores on the first 4 quizzes, you can skip this one because we're going to drop your worst quiz. Or to be more specific, we're going to max it out to 20. Whatever your worst score is, it goes straight to 20, okay? That makes the math and organization easier for us than dropping something. Anyway, the topics, and this is going to shock you, going to be box 2D. Okay, make sure you understand what a fixture kind of is, all right? What a shape is, what these properties do, like what is restitution, okay? Make sure that you revisit that box 2D lecture where we go over a couple of the foot guns that box 2D has, like you can have a B2 body, but if you don't have any fixture on that body, you're not moving, okay? Check that stuff out. Just remind yourself of it. Shouldn't be too bad. And we're going to have some very basic questions on ECS and data-oriented programming. Nothing that isn't in the lecture we did on Monday. Okay, so you're going to want to go back, quickly review that. At the very least, so you know where certain things are, you can get back to it quickly during the quiz. Okay? All right. I've been getting nervous. You know why? Because I got some students who are messing with my my course schedule. They've started on custom features already. Very impressive and very fun to see. I have to decide now whether I'm going to let the students use this stuff that they made before the assignment even started. So that's kind of a course design thing that I have to figure out. But Arnav created a web export. Arnav, are you here? Ah. How'd you make this?
It's just a compiler you can use, like compile C++ for web, for lots of.
I'm pretty amazed that it knows how to compile the SDL calls and the SDL underlying tech.
I think they have some special build-ins for SDL because they have like some special support for that.
That's what I think, and it really creeps me out a bit because that means that for any sort of popular rendering framework out there, there has to be some like bespoke written code by the, is it Mscripton that you used? Yeah, the Mscripton team has to go in and be like, oh, a new live graphics library is popular? Okay, we got to go and write some custom code for that. That stinks. Yes?
So with SDL3, I think, and later SDL2, the SDL team just added the support.
Ah.
In the early versions of SDL2, the Mscripton team got hacked in there.
That's much more sustainable to say like, hey, it's on you. Like you're making SDL, you need to make sure that these popular compilers will work well. But this probably didn't take much time, did it?
It was like 4 hours.
4 hours? That's not zero time. So one question, if you've already started on some of this stuff, is how can you take this even further? We do want to see in these final 2 weeks that you're putting in good time, okay? And if you're already finished with something like this, it kind of makes it hard on the staff to say like, wait, are we going to accept this? But we probably shouldn't. What we'll probably end up saying is this is awesome, very good starting point. What do you want to do for the next 2 weeks to make this even better? But it's really, really cool, isn't it? I think a lot of people saw this in the Discord and were like, whoa, this is WebGL. You know, I had an idea midway through the semester that I would upgrade the autograder to have it automatically generate WebGL versions for all of you. And then basically on your grade report, it would say, hey, don't download this test case, play it in your browser right here. Just click here, okay? Wouldn't that be cool? I think that'd be pretty cool in big part because with a link, you can easily send that to friends and family, can't you? Right? Wouldn't it be cool, for instance, with Donna's Cute 'em Up game, to be like, hey, my engine brought this game to life. Hey, fam, would you like to play it? Here's my link. And it just works, and it's pretty great, right? I think that would be super cool, and maybe we'll do something like that. Anyway, cool. Good job. Very impressive stuff. I'm really eager to see kind of what the performance is like. I'd like to see a performance test done maybe. But everything seems to work. Box 2D is working just fine. Controls, were the controls okay?
Yeah.
Just exactly the way you expect?
Yeah.
Did you have to like click on the browser before?
Like click on the canvas window.
Okay. Yeah, that's usually how it goes. All right, we got another one. This is Nick Cerrone. Are you here, Nick? No? Maybe? No? All right. This was Nick Cerrone that got a joystick support working. Okay. And that's always cool to see. It looks like we've got 2 thumbsticks going here. It's a bit hard to tell exactly. I'm going to say I kind of suspected these 2 would be some of the easier tasks to do in the final 2 weeks. I'm glad that it kind of looks like I was right. But one big question for Nick would be, this is really great, but what kind of API are you going to design? We got input.getKeyDown, right? That already exists, but how do we give players access to 2 thumbsticks. What does that mean? Do we give it to them in the form of a B2 Vec2 or a GLM Vec2? Do we give it, what's the function call going to be named? So it's just really, really nice and obvious and easy to use. That's actually the kind of work that I'm really excited to see some of you do, some of the API design, thinking about not only how do I build this cool deck, but how do I get this cool tech out to my users so they can use it easily, right? That's the really interesting stuff for me these days, at least. But wow, super cool. I can tell a bunch of you are chomping at the bit, and I can't wait either. My impression is that it's going to be a relatively easy 2 assignments to get most of those points on, so long as you put in a good amount of time, okay? So that'll hopefully make it satisfying as well. You're going to put in a good amount of work, you're going to get a lot of points, right? It's always a good feeling. Nick is not here. I wish that he was. He's produced engine documentation for us, okay? He said, Austin, your assignment specs are great, but they're not super good documentation-wise. So Nick went and produced a GitHub page. I think we can get this in the form of a Git repo in case you want to clone it and customize it for your engine. But this is the documentation page for the A2 engine, which is kind of our custom, course standard engine and all of its APIs. We got stuff like the actor class, right? You got the get name function, you got get ID. We've got example code for each of these on how to use it, which is always really great. And you realize there are actually a surprising number of functions here. It's not a massive API. It's a pretty minimal one, but not too much is missing. It's not too bad. My main regret of this course might be not doing actor.create. Because instantiate's kind of a funky word that a lot of people haven't heard. It's a little bit of a tongue twister, a little bit painful to say, and it's spelled in a way that might make people a little bit annoyed with it, especially if English is not your first language. Create is just a much more obvious, shorter, easier to say word that gets the point across easily. So I might have messed that up. Okay. All right. Okay, I think that's it. Very cool documentation. You can get it, grab a copy on this agenda right here if you want to. Maybe you'll do that in the final 2 weeks. I'm fairly sure that the assignment is not finalized yet, but I'm fairly sure at the very end of the semester, your very final assignment will require you to produce a basic static website with downloads, binary downloads of your engine, with your custom feature. So if anyone out there wants to use your engine, they can use it. Okay? That's the whole point, isn't it? Your recruiters can download your engine. Maybe you should send a sample game with it so that when the recruiter runs your engine, it pops to life like the Donna game or something, right? Instead of just instantly crashing or something like that. Because they're going to do it. Someone's going to see you made your own engine. They're going to see on your website that it's downloadable. They're going to go to run it, and it better run. Right? If it crashes, that's kind of like, well, I see you made a broken engine that barely works. That's not very useful. Anyway, we'll talk about that more in that final week. We'll talk about what you need to submit to get all those points, okay? There are other courses relating to game dev out there. Many of you have heard of one of these. I think something like 50% of this course's students came from either 494 or EECS 440. If you are really passionate about game dev, and you are in this course, so there's a good chance you are, packing your portfolio with other projects, with other courses, not a bad idea. And I'll tell you, after what you've gone through in this course, these other courses might seem pretty easy, okay? 494 has a tough reputation. It is a tough course, but the technical parts of the course, learning game engines, learning Unity as quickly as possible, that's something you're already kind of familiar with because our engine is kind of basically Unity, okay? It is focused entirely on Unity, and it is all about game design. Well, in the second half at least, okay? It is a very difficult course when we get to that design aspect. Often we know how to make something, but we don't really figure out what to make. And the things that we make just don't work well for others, for users. And so this is a really good course if you want to practice your design chops and get really, really good with Unity, okay? Which is an engine that a lot of people use, a lot of opportunities, a lot of jobs for Unity. You're going to find yourself doing things like re-implementing Legend of Zelda, 1986 Nintendo game, or Metroid, and you'll, of course, be adding your own things onto it. For example, a motorbike that is well-guided and escalates in a very nice, smooth fashion that difficulty curve, introducing new uses for the bike with every room, okay? This is the kind of stuff we focus on. Not only can you make a motorbike, but can you find a clever and seamless way to introduce it and then escalate its usage over time, okay? That is the stuff that is truly difficult, all right? The topic of interesting decisions, guidance, juice, professionalism, all that good stuff you'll learn about in EECS 494. Give it a thought. If you already have a capstone, then this will not be an upper-level CS for you, okay? It is a capstone/MDE course. You need one of those to graduate. 494 could be it. And, of course, you got a very big showcase event that you get to enjoy, and you get to make a very big game, okay, at the end of it, for 6-7 weeks on a team to 4 to 5, okay? So could be useful. You can visit EECS494.com if you want to learn more about that course. If you've already taken it, hopefully I haven't triggered you at all. Yeah, let me know if you have any questions. If you're looking for something a little bit more unique, if you're looking for a capstone course that's a bit easier, a little bit lighter weight, something that you could mix with a 482, then EECS 440, the XR course, is definitely a choice and something that you might consider. Unlike EECS 494, this course focuses on Unreal Engine, which is a very popular, very successful engine. If you know it, if you only know it a little bit even, there are a lot of opportunities that will open for you, okay? Lots of jobs in game dev and outside of it use Unreal Engine these days for various reasons, and this course will get you some pretty decent exposure to Unreal, okay? It is much lighter than 494, and also much lighter than this course, Game Engine Architecture. It is about Unreal Engine, but in the context of VR, AR, and there's some Unity in there as well. So you'll get a refresher on Unity, especially when you do mobile AR stuff, okay? Very good idea for anyone who wants to work in game dev or visualization or extended reality in the future, okay? You will make things that are not traditional games. You'll make things for non-recreational reasons. I'm going to show you 2 of them. I'm going to show you a workout fitness game called Urban Rush. Let's go ahead and take a look at that trailer really quickly.
Are you ready for the ultimate fitness challenge? Introducing Urban Rush, the virtual reality fitness game that will push you to your limits. With Urban Rush, you have to dodge cars and squat under gates, all while getting a full body workout. But the challenges don't stop there. You'll have to fight off zombies and robots to survive, and with the new levels and challenges added regularly, the possibilities are endless. It's getting harder and harder to make time for fitness. Let's get fit at home while having fun. Thanks to virtual reality, you can squat, swipe, and step your way into a world designed to make you move.
One really cool thing I like to point out about this fitness app is that level design, where the designers choose to put these signs you have to duck under, where they choose to put the coins, has a huge impact on the workout you receive. They can get you, if they want you to do squats, really intense squats, what they can do is they can put a sign right there to cause you to have to crouch, right? Go low. And then right behind the sign, they'll put coins in the air, forcing you to jump up and grab them. and then a sign right behind the coin. So you have to go down again, jump, go down, right, jump, right. And you quickly, like, you're going to break out in a sweat when they do that a few times in a row. Guaranteed, okay? So very impressive stuff. The team did a good job. A fitness app, good idea. Let me show you really quickly. Face AR. I really like that one. This course is not about recreation. It's about social impact. So you're looking for something, whether that's educational or health-based or artistic or whatever. You're looking to make something that has some sort of non-recreational social impact. Let's take a look real quick. Here it is, Face AR. This one actually got I think a $30,000 grant, $30,000 grant from Snap. Funded by Snap AR. Let's take a look at the trailer. This is an actual patient.
Face AR is an augmented reality app that helps patients with facial disabilities perform exercises through immersive games. So the face tracking technology used by this app is a lot more useful engaging the patient rather than just looking at themselves when they don't want to in front of the mirror, but to use the app where there are games that engage them and they're able to quantify or by direct feedback in AR what their exercises are doing their face would be very helpful. Currently, the facial therapists are difficult to find. They're not readily available, and this app would provide access to everyone.
Okay, so usually you're not able to do this. It was shocking to me that the team was able to go to Michigan Medicine, find a patient in need of facial rehabilitation, and then just hand the app to him. Like, usually you have to go through a lot of bureaucracy and a ton of paperwork to do something like that. But the team managed to make it happen, and just incredible stuff as a result. Anyway, right, very cool stuff. It's the kind of stuff you can work on. It might be unique for your portfolio to get some VR and AR projects on there. So consider it, especially if you have a harder semester next semester. This might be a good course to kind of slip in there. Not too heavy, doesn't take too much time. It's definitely a medium or moderate workload course, okay? The last thing I want you to consider is Wolverine Soft Studio. This is the big team that is student-run. It is very much student-run. I do not interfere with this team much at all. And they put out a ton of games. You can learn more about the studio and how it works here. You can apply to it. And I'll tell you, if you've made your very own game engine, I think there's a pretty good chance you'll get some interest from the team, okay? Yes?
I just want to say applications will probably open up by the end of April, so I would get ready by then. If you don't have any kind of portfolio to show, just put some stuff in a Google Doc. I promise that's good enough. That's what I did.
Yeah, put your game engine in a Google Doc, and you're good to go, okay? This is a great team. You will learn a lot being on a team of not 4 to 5 people like you are in EECS 440 or EECS 494, but being on a team of 40 people. You will learn a lot about organization, about how to keep people efficient, and keep people aligned and moving in the right direction. This is a team that puts out a lot of games. And they put out games on itch.io. They put out games every semester, at least one game per semester, sometimes more. They do that on Steam as well. So just wonderful for your portfolio if you really care about game dev.
I just want to say one more thing. So if you have any questions about Studio, you can talk to me or Nikhil. We're both leads in the Studio. Additionally, we have Wolverine Soft Club. There's like regular meetings, like no Studio, you don't have to apply or anything. Join every Thursday. So if you just want to get to know some people in Wolverine Soft before applying for Studio, or you just want to come hang out and talk about games, every Thursday until the end of the semester, we have our regular meetings. So also join the Discord if you can. I don't know where that link is, but again, I can get it to you if you want to join.
Yeah.
Also, I'm over here and I'm Jacob.
Okay. All right. So I think what we'd like to do here today is we're going to end early and give you extra office hours. But before we do that, Ravi is here with the Rav engine. And he's going to show us what it's about, show us an example of data-oriented programming, show us an example of ECS, okay? I'm going to keep my laptop going because we need to, I think I'm going to position my laptop to show the screen because I don't think you can stream your screen. You don't have
I will need to hook up.
yeah. Okay, so let's go ahead and do it. Do you have Macs? You've got, okay, we've got HDMI, and I think we've got USB-C here. Here we go. It's amazing how Apple just forced all these dongles to start.
Well, and then they reverted. So now the
yeah.
newer model has the
USB-C. Has the wrong one?
No, it has HDMI now.
Oh, does
They
it?
actually added it back.
Oh,
But
really?
This
wow.
is a 5-year-old laptop, so it doesn't have it.
Okay. All right. For everyone watching on the stream, I'm going to try and get it. Let me see if I can get it organized here for you. And then maybe I can make this bigger. Yeah, there we go. And you'll probably be able to hear Ravi as he talks, and you'll be able to see the screens.
Okay, we'll make the text bigger so that you can see it.
Yeah, hopefully this won't be too illegible here. I'll zoom it in a little bit, maybe. Okay.
Is this a good text size? Everyone can read what this says up here. I can make it a little bit bigger if needed. You said make it bigger?
Yeah.
Okay. All right. Let's make it like super large. That might be a little too big.
Cool. So, yep. Speak loudly.
Yeah.
No microphone system in this.
Okay.
In this room.
Is this a good size, or should I give it this little big? Anyway. Okay. So yeah. So this is a game engine that I've been developing for like 3.5 years, I would say. It started as a COVID project, and in a lot of ways, I designed it to be kind of like the anti-Unity in terms of how it works. Just because I have used Unity and I don't like it. I've used Unreal, I don't like it either. So I want to make something that kind of works the way I want it to work. And one of the ways it does that is it's data oriented at its core. Everything in the engine, all objects, everything behavior wise is done in a data oriented way. And I'm going to kind of show you what the programming model of that's like, as well as how it's implemented underneath the hood. I also kind of talked a little bit about like how you even make a hello world example for and you can compare this to how the A2 engine does things and how Unity does things, how Unreal does things. So one of the things about this engine is it's purely a code engine. There's no graphical editor. There's no metadata files. There's no JSON. There's no there's nothing. There's only code. So kind of the first thing you do is you create an app subclass, and this gives you your initial hook, which is where everything gets going, and we can implement that down here. And then in your app, like we can set the title of the window, but then we also want to create a level, or a world is how the engine calls it. I mix the terms sometimes. And these are like your scene. Now, one thing that's different about this engine compared to yours is that you can have multiple scenes loaded at once. And in fact, you can actually have multiple scenes ticking at once as well. Only one can render at a time, but the kind of reason behind this is that you may want to like load a world in the background and then switch them and have like a seamless transition, which is difficult to do in single world engines, but in this one, it's quite easy to do. So once you load your world, it returns a smart pointer, so that you don't have to delete it. And then down here we have this thing called start app. It's like, well, what does this do? Well, because the engine is a code only, it doesn't have a runtime. So something has to kickstart the engine to going. That's what this macro is for. So if you go inside of it, you'll see that it creates a main function, which is make uniques the app, and then calls the run function on it. You don't have to use this if you don't want to, but it's convenient to have this. So once you've created your world, you have a constructor. You derive it off of the world class. And then here is populating a scene. So if you imagine, if you remember from the engine that you're developing, you have these like scene files that contain descriptions of all the objects in them. And then you have like templates so you can spawn multiple of something. In this engine, there's just API calls to spawn things in the world. If you ever use like Apple's Scene Kit, this is very reminiscent of that. It's, you calling functions to spawn objects and add things to them. The function is called create prototype, which is a really unfortunate name for this function because it has nothing to do with prototypal inheritance. It's not a prototype, it's the actual function that it's going to stay there. But it's called that. I don't know why I remember it named it like that. So then we have this thing called the game object. Now, it's like, well, in ECS, what's this doing here? So if we go visit it, we'll see that a game object derives off a thing called entity, and all it does is add a transform to it. And so we'll say, what's an entity? Well, let's go look at that. And we'll see that an entity, if you remember from lecture on Monday, this will start to look a little familiar. We have an ID for this entity, and then there's no other data members in here. There's just a bunch of convenience functions. And so this entity is just a 32-bit handle that the data structure tracking internally uses to know what object you're talking about whenever you want to do something. So what we can do if we go back, you see that we're returned this struct, and then because I wanted to make the API kind of nicer to use, you'll see a lot of ECSs will go entity manager, add component, then you could pass the entity, and then you pass the component. I didn't like that, so I just put convenience functions on there, which go underneath. They go to the global registry tracker, which then maps it to whatever world you're in. So, for example, if we just run this code, you'll see top to bottom, it's only 10 lines. We'll get a cube on screen once it starts up. It's there you go. I promise that's a cube. It's just aligned with the camera, so it's like a square. But so then you'll notice that I have commented out this thing right here. So because this is an ECS, what ECS stands for is entity, component, and system. And those are three separate terms, and they compose what the architecture is. So the entity is that handle, which ties components together. Then components are your data. They can be anything. They can be and we'll show an example of what those are and kind of how you create them and how you put them on things and what you do with them. And then systems are where your game logic goes. These are functions, and they operate on the world to have things happen. So for example, if I uncomment this is an example of what a system looks like. We have a function in it. This is the call operator. And in here, I'm accepting transforms. And so every tick, I'm going to rotate this transform on the y-axis by 1 degree. And so we have to tell the engine that we want to use it here within play system. And when I run this now, we're going to see that something changes when I do this. And it does take a little bit to compile. This is one of the unfortunate things of being a code-only engine, is that you have to rebuild a lot of stuff. Just kind of how it goes. Yes, then it's going to boot up. And we'll see that the cube is turning, but so is the camera. And actually, you'll notice that the light, even you can't really see it that easily, but the light's actually turning too. And so let's look at this closer. So all I did was add this line here and then define it here. And so what it's doing is it's reading the function signature right here. This is a really, really primitive form of reflection. It's reading the function signature and just saying, okay, this system wants all the objects that have a transform, which in this case is every single object in our scene, because the light has a transform, the camera has a transform, and the cube has a transform. So you might say, well, we don't really want that, right? We may want to have what if we only want to have the cube turn? Well, there's no way to do that right now. So what I'm going to do is I'm going to make a component. Let's do spin component. And so just by doing that, we have a component now. Now it's just a struct. You can do anything you want. So let's say I want to customize the speed that we spin. So I'm going to say spin speed. We're going to give it a default value. We'll make it 2 so it's different. And then we're going to go to our cube entity, and we're going to go cube entity dot and place component, and we're just going to stick that in there. We don't have any constructor args, so we're going to ignore that. And I'm going to go run this, and we have a spin component now. When we run this, give it a sec. So rapid prototyping is a very important thing for engines, and that's one thing that this engine fails at. So when you're designing your own engine, make different decisions. You'll notice that everything's still spinning, right? Well, because our system is still looking for transforms, and so you say, well, I want to mutate the transform. I want to read from the spin component. So what we're going to do here is we're just going to say I read a const spin component. I'm going to call this the config, and we have a transform. And so now I'm going to do like we have our component here. So I'm just going to replace that with spin speed. And so when we run this now, we'll notice that the result changes. So, oh, it failed. What did I do? Oh, yeah, right. This is not C#. You have to do it that way. So I'm doing it all in one file because I can and because it's easier to demo that way. But ideally you would stick this struct in a header somewhere and then just import it into your code. So then I do this now. Once it starts up, see, only our cube is spinning now because the light and the camera do not have the spin component on them, but the cube does. And we can put more data in here. Like I could add, all three components and then put them in here. So let's do something else. Let's add more cubes. So what I'm gonna do is I'm gonna add a loop here. Let's make 5 of them. And what I'm gonna do is we want more of this, right? So I don't want to copy paste this all over the place. So what we can do is we can create another like a preset essentially. So I'm gonna call this cube object, and we're going to derive from game object because that's what we had here. And then if you remember from game object, if we go look at it, right, that's this create function. So what the engine does is it calls this create function on the top level defined type whenever you call that create prototype function, and that's like our hook. So we're gonna have one of those, and then we want everything from game objects. So we want this transform. So we're just gonna call that there. Wait, that's the wrong, yeah, like that. And then we want to have all of our stuff in here. So I'm gonna replace this. I'm gonna do auto entity equals create prototype, and we're gonna say cube object. And we have something we're gonna do in there. So this right here, this is actually something that I added because I was frustrated with how Unity and Unreal both do object instantiation, where you can't give parameters to it. You have to just spawn them and then like get component on stuff and like kind of stuff values in there, and like that's your construction. I don't like that. That's kind of gross. So what you can actually do here is we can pass parameters to the create function, and the function will actually detect that you passed something here and forward it on to the create function. And so then you can do your kind of inheritance, and also you can, unlike C++ inheritance, you can actually do this out of order. You can add your stuff here and then call create, or do it the other way, which is often not something that most engines let you do. So the reason why we're passing something in is because of this right here, this material instance. And we don't really have to. Like I could legitimately just take this exact code, and we might just do that for time's sake. But the reason why is that these material instances are what tell how the engine decides how to collapse draw calls. And so if you have unique instances, it's going to go, oh, these are separate materials, so we have to draw them individually. So if you spin in a loop and call a bunch of these, it's not going to know to collapse them. But if you pass it in, like say I'm going to load the material once and then I'm going to pass it in, then it knows we have one material instance and n references, so then it can then draw it with a single dispatch instead of multiple. That's kind of out of the scope of this class, though. That's like, if you want to know more about that, maybe take the upcoming graphics course. So we have an in place component on the cube, so we don't have to do any of that anymore. We have this now. We also want the spin component, and what we can do now is I want to customize the spin component when I spawn it. So we're gonna make a constructor for this. Actually, we may not need one. Actually, I don't want to find it out. I'll just do that. So that way we can give it a value. So then I can say we have a default value of 2, but you can also, we'll say, give it 3 as its value. Then I want a bunch of cubes, so I'm going to put it in here. And so this is going to spawn them all in the same spot if you do this. So what we may want is we actually probably want some way to differentiate these when we spawn them, like tell it, well, actually we don't have to pass it in. We can just do transform set local position. And then we will just set this to, right, my coordinate system is x horizontally, so we'll just say this is I, 0, 0. And if I have done this right, then we should see 5 cubes on screen, kind of one after another. It might go off screen, but what did I? Oh, yeah, right. Don't need that. Oh, and also I. We also need to put it in front of the camera, otherwise it's going to be inside the camera. Actually, no. Instead of doing that, why don't we just move the camera out of the way? That would be smarter. So we can say camera entity dot get transform dot local translate delta, and we're gonna move it backwards. And it's like this is using OpenGL coordinates, so it's positive y up, x is horizontal, and then negative y is into the scene. It's just easier for me to do it that way. DirectX does positive z into the scene because that's kind of more expected. But you just choose a coordinate system and then you stick to it. And once you stick to it, then everything will make sense to your developers once they understand how your coordinate system works. So we're going to build this, and then once we run it, we should see 5 cubes off screen. And we do, and we see that they're all spinning. We might want to shift them over a little bit because they're off screen. So let's where did I keep that? Let's do I minus 25 so that they shift over exactly halfway. And then I'm going to say we want to give our component like some unique data per instance. So what I'm going to do is I'm going to say we're going to be able to pass it in when we create the cube. Spin speed, pass it right there. And then we're going to replace that here. And then I'm going to set the spin speed when I create the entity. I'm going to set it to I. So the first one's not going to spin at all, and then each one's going to spin faster as we go. And so once it builds, that's what we should see. So it builds, and then you open it, and see that's exactly what we see. And you get kind of a trippy effect when you do that. So then there is one thing that's happening here that isn't obvious from looking at, and that is that because we have all the inputs defined here, the engine doesn't have to do these sequentially. In fact, it doesn't. It will automatically parallelize this. What we're going to do here is I'm going to run it again, but I'm going to set a breakpoint inside of this call operator. And so this will tell us what thread everything's running on. So you'll see that like thread 10 was allocated to run that cube. If I press continue again, look at the next one, and now thread 8 did this one, and thread 6 did that one, because these don't have interdependencies. And so because we know that the internal structure isn't going to like change across all these calls, it can just automatically go live for you instead of calling them one after another. And in fact, we can actually do more of that here. So now my engine doesn't do it currently, but this is one thing I do want to do eventually, is that because you actually have all of your read and write dependencies just specified here, when you load in systems, the engine could actually build a graph of read after write dependencies and just tell you if you have two writes to the same component or read after write without a dependency inserted. So I guess we should talk a little bit like, how does the engine internally actually do this? Because just right now it looks kind of magical, right? I just kind of define this thing and then it just sort of makes it happen. So all the magic is in this file called world.hpp, which is, you can see I created it quite a while ago. That's when this was started. And I might have to zoom it out because it's just, yeah. So you'll see things like destroy, get component. So the way that it works internally is this thing called a sparse set, which I guess we're going to cover soon, Austin, right?
Yeah, probably.
Yeah. So you might if you've ever heard of how ECSs work, there's two kind of implementations people go for. One called archetypal and the other one called sparse sets. This one uses sparse sets. Minecraft Bedrock also uses sparse sets, and Unity Dots is archetypal. But kind of the main thing to know is that from an API level, like you often don't have to care what the internal thing is doing. Like this is going to be the same, regardless if it was archetypal or sparse sets. But so essentially what a sparse set does is we want to have a couple of data access patterns that are useful for both game logic and also for the engine internally to be efficient. And those are, we want to be able to iterate over the container efficiently. We want to be able to divide the container and all its data across multiple threads evenly. We also want insertion and deletion to be constant time, ideally. And we don't care about the order of the elements necessarily. Once they're in there, it's like, because they're being run in parallel, what order they even run in is often up to the scheduler anyway. So what a sparse set does is we have three containers essentially. One of them is called a dense set. If I can find one in here. Dense. Is this one of the implementations? Just checking one sec. Yeah, sparse. This is one of the weird versions of it. I think I have one. Yeah, I do. Okay, so this is like a sparse set implementation, and so we'll have the actual. We have two or three containers. We have the dense set, which is every element back to back in memory. There are no holes in this data structure. But so you might think, well, how do we know, given an input, like where it is in the data structure? That's what the sparse set is for. The sparse set is its size is like the highest index, and it maps your sparse, your global index into a dense index. And so we might say, my handle is ID 5, so I'm going to go to location 5 in the sparse set. And sparse set tells you if you want to find the data for that entity, it's actually at offset 2. So you offset 2, and that's where data is. And then the reverse map is given a dense index. I want to know who owns it. And so that tracks for a number of dense elements what the sparse index is. So you can go back and forth. And so when you erase from the dense set, this is kind of the thing where we don't care about ordering. Instead of having to shift all the elements down, which is an order of n operation like vector does, this employs a container that I kind of got from the internet but wrote myself called the unordered vector. The unordered vector does, when you delete an element from the unordered vector, which might actually be in here. Oh, it's not. Unordered vector. When you erase it, okay, that's not a good example. It will take the element at the end of the dense set and move it into where the hole was. That way, it stays back to back. And you might wonder, like, why do we care about having holes? Doesn't seem too bad, right? Well, one thing is if we wanted to know if an element was allocated or not, we need a fourth data structure. because we wouldn't know if given in some data, if it's like correct or not, if it represents a valid object or if it represents nothing or represents a dead object. We have to have yet another structure. But also, if we're iterating that structure, if it has holes in it, the compiler cannot vectorize it. And so what vectorization does is it's features of hardware which allow the CPU to process multiple elements of a list of bytes with a single instruction, single clock cycle. So you can get speeds ups of 4x or 8x depending on how wide your vectorization task is. And you cannot do that if there's a branch in there. It has to assume that every element could be invalid, and so it has to process all of them sequentially, and so you take that 4 or 8x perf hit. Of course, if you're doing complex game logic, that doesn't matter at all, because like you're not going to be vectorizing like a complex character controller. But for high count, low complexity objects, which often inhabit a scene, like plants or bricks or traffic cones that you can knock around, you want to encourage the compiler to do that as much as possible. It also means that you don't have to check, like when we're dividing the vector by thread, we can just say, oh, just divide it by n, and then this is the first chunk, second chunk, third chunk, fourth chunk. You can just send them off. You don't have to track where the holes are and then kind of block around them to ensure that all the threads are evenly split. And so the next question is, well, we're storing kind of heterogeneous data in these containers. We need to have like a master container, because you notice that I didn't register this component anywhere. I just kind of wrote it here, and then the engine somehow knew what to do just automatically. Same thing with this system. I didn't specify that. I didn't give it an ID, and that goes into something inside the world component map. Let's go to this work. So here it is. So it's this is where all the magic happens. So look at what this is. This is a hash table, and we're matching this thing to something called any sparse set. So this is kind of one way that the engine you can work around the fact that you don't have runtime type lookup in C++. At least not a good one. There is RTTI, but in the context of real-time application, you do not want to use RTTI because it operates using strings. So it allocates strings and it does string comparisons to make sure that things match, which you do not want. So ideally, we'd have some kind of like numeric ID that we can say at compile time. Because if you look at, like we have the type just kind of known here, like at compile time. So ideally, we would be able to persist that information into the data structure when we compile it. And so that's what this is. This, if you look at what this is defined as, it's a size t. So 64-bit integer. And we're in the header called TTI T.8 HPP. And what's going on in this file is we know we have a unique type. We have to tie that type to an integer at compile time. And so what this is doing, I found on the internet, and I have the link posted here, a compile time string hashing algorithm that somebody created. And what this does is, using some more very primitive reflection, actually grab these exact names like SPIN, COM, PONT, and it creates a hash of that value. At compile time, using constexpr and consteval, you can see that for different compilers, you often have to do different things because the strings are not stable across compilers, so it has to work around that. But once we have those, if I call like CTTI of spin component, I will get back a number that's almost certainly unique. Now, it's a hash, so you can't have collisions, and so the workaround for that is if there's some case where you somehow have a collision, you can override the string to be something else, and then you can avoid the collision that way. And so that allows us to, at compile time, look up a type at runtime from its ID at compile time. And I have this thing called the any sparse set. And the any sparse set is a wrapper around the sparse set that allows us to store different types of sparse set inside of one container, which is crucial for being able to do data lookups because we don't know what's going to get called. And so we have to somehow be able to, at runtime, resolve that without too much overhead. The any sparse set does it takes advantage of kind of an implementation detail of how the vector works. And that is, if you know how vectors work, inside a vector, there's 3 pointers, and because the sparse set just consists of vectors, the inside of the sparse set is just pointers. So what that tells you is that it doesn't matter what you're storing in the vector. The number of bytes that the vector is always going to be the same. So what we can do is we can reserve a class which has like some memory inside of it, which has enough space for a sparse set. And I can pick any of them here because all sparse sets are going to be the same size. And then we need some way though to like reverse the fact that we've just lost a whole bunch of information by placement newing something in here. And so that's what these functions do. These functions capture, we can generate like a lambda, which you may have used when you're implementing your engine. But what that allows us to do is, using a template, we can generate a function which has the right type in it. And then we can assign it to this function. And function, which is, this just maps SD function under the hood. SD function is something similar where it also has a buffer, but it also has the ability to store like where the call site is so that it can then go and call your function. And so whenever we want to like add or remove something from these vectors or these sparse sets, we can go through these trampoline functions to do it. That's what these here, the dealloc, destroy, move entity. So these all go into the hash map, and this hash map has some locking on it so that you can call it across threads, because remember, it's throwing things onto random threads, so it has to be stable in order to do that. And it uses a very inexpensive compare and exchange lock instead of mutex, because mutexes are quite expensive, but we don't even want all the features of a mutex. We just want the ability to block a thread cheaply and then unlock it. So that's what this does. And so now we have a way to store anything we want in this container. And we also have the ability to know what's in the container by looking at these IDs. And we also know that because the containers all have a known layout, we can read any component we want from it. So that's our storage. But how do we do the lookups? So there's a bunch of optimizations in here, but the way that it works is actually conceptually very simple. So the first thing it does is when you call when it goes to tick your system, which it allocates internally, and it has this list of components that it knows the system is going to operate on, and it knows the system will only ever operate on these values because it's static. You can't change it at runtime. And so what it does is the first thing it does when it's time to tick is it goes, gets the ID for this type, which it actually had already done. It just has a list of IDs. And it's this first one here, and it goes and it grabs the sparse set in the component map for that particular row. Then, if you have more than one component, it will then iterate down this first component's vector dense set, and it will check if any of the entities in that vector have the right component. If they do, then it calls their system. Otherwise, it doesn't. So one way to optimize this code is sort your components in here by least common to most common. That way, you've your worst case iteration is the smallest possible vector, not the largest one. So it's going to allocate fewer thread resources, and it's going to check fewer things. And you might say, well, that sounds kind of inefficient having to go and check. But because the sparse set is so simple, you can actually get away with a lot here. Like I have a demo, which unfortunately I don't have compiled, so I can't run it, where I have like 6 million of these entities with multiple components on them. I'm able to run these systems and still achieve 60 frames per second. So you can be really, when you have things laid out in a way that that computers prefer, which is keeping everything cache coherent and minimizing the amount of jumps you're doing, you can actually get away with quite simple algorithms. If you look at online, there's a library called ENTT, which I use as inspiration when designing this system, which does even more involved things involving moving components around based on analysis of your access patterns at runtime. I did not do that because that's very complicated. And also, you don't need to. Like, again, 6 million entities at 60 FPS, like what game even has a number of objects? Like none. So do I have anything else I need to say here? guess I can open up for questions if anyone wants to know anything specific about how this is implemented.
Questions?
Yes.
So, do you have a scene file format at all, or anything like that? Or do you trust the developer to make their own thing?
There is no scene file format. This is the scene file format. It's code. The idea being that I decided I cannot predict what a game would want for its scene format, and so if a game wants to use the tiled system, like they can just integrate that and then be done, or they can do it in code if they prefer that, or they can design a format like we did in this class for your engines. And also because I'm making simple test apps, I don't want to write a scene file format. Yeah.
The repo has a bunch of stars. There are a bunch of people looking at it.
Let's look at the repo.
Do you know of any projects that are using RapEngine, or at the very least, have you gotten any feedback from any external parties who have played around with it?
Yeah, actually, I have. I don't know if there's any active projects that are using it, but I have found people who have at least tried to use it. I think a lot of them, it's still a very technical engine to use, and so I think a lot of people get scared away by that. But people have evaluated it. They've given me feedback. They found bugs and reported them. Some people have actually PR'd fixes for those bugs. Like if I go to pull requests, this one, someone found that I forgot to make something just virtual, and so they fixed that. Another person found a crasher on Linux where if you called query scale factor on the window, it would crash because I didn't test that code path, and so there was just no code there.
Yeah.
And scale factor, that's your UI scaling size for high DPI screens, for example. And so I've tried to make it as portable as possible, and so this is the list of all the stuff that you could run it on. Mac, iOS, Apple TV, Vision Pro in 2D mode, sort of. Windows again, Windows did it another way. Xbox, if you're using IDE at Xbox, if you're not an NDA programmer. Linux, Android, sort of, and also I'm trying to get in web builds working. The thing is that because this is a 3D engine, the complexity of getting 3D working on the web is much higher. In particular, I have to write a web GPU backend, and I found a bunch of bugs in mscripton's web GPU bridge, which is blocking me right now. So I'm just waiting for them to fix those things until I can actually go and implement a web GPU backend. Also, I don't own this or this, and so I'm just assuming that the platform vendor's simulator software is accurate.
Gotcha.
And at least the Vision Pro one seems to be, because the iOS one is, and the Android emulator, I think, is an actual emulator. It's not a simulator, so if it works there, it should work on a real device.
Gotcha. Thank you. Questions? All right, Ravi, thank you so much. Very cool stuff. What did you do during the pandemic? Okay. All right. So I think that is pretty much all we've got for you today. We will have more stuff for you beginning next week. Of course, the exam review is going to start happening next week. We'll be talking about some of that. And then after the exam, we will have some more guest lectures. We're going to have Stardock coming. They're going to be talking to you about some industrial grade C++ techniques and practices they use at Stardock, as well as talking about their engine. And we'll have some other topics to talk to you about as well that may be of interest. Okay? And so I think that's just about it. Does anyone have any final questions before we launch into office hours a bit early? Okay, I'll throw some music on and we can start working our way through Homework 8. Okay? See you in just a bit. Everyone, hopefully you were able to see that, Ravi's screen, and hear him okay. Thank you so much for joining us, and we will see you later, okay? Check out RAVEngine, R-A-V engine. You should be able to find the GitHub repo very easily, okay? Take care, everyone. We'll see you next time. Bye-bye.